Today we are going to look at identifying corresponding sides of similar figures and compare their ratios. So I want you to think of a copy machine. If I was going to put something into the copy machine to either enlarge it or reduce it, I would put in a percent. Maybe I would put in 300% because I want to blow something up. I want to enlarge it. Now when it comes out, it's going to be 3 times as big, but it's not going to become all distorted. Every part of that picture needs to have increased by a scale factor, we call it, or a multiplier of 3. It needs to have gotten 3 times as big. So two figures are similar if they have the same shape, but not necessarily the same size. So all of the lengths of a shape have to be related by a multiplier or a scale factor, and it has to be the same one. So we're going to do a couple examples to show you guys what I mean. So let's start with these 2 shapes here, these 2 triangles. So I have triangle ABC and triangle DEF. Now you'll notice that they have the same shape, but not necessarily the same size. So I'm going to say that this is my original. The smaller one's my original, and I'm going to put it into a copy machine. And let's say that I want it to be twice as big. So I'm going to say, so my multiplier is 2. Okay? That means every single part of the copy has to be twice as big as the original, which would make this side length equal to 6. Now that's because this side length AB is corresponding to side length DE. They're in the same place on the shape. Okay? Just like this side length EF corresponds to BC. So if I want, I need to multiply this by 2 to get 4. And then I also need the last side length. So 4 times the multiplier is 2 is 8. So at this point, I would say that these 2 shapes are similar, and they're related by a multiplier of 2, or a scale factor of 2. Now because this is the original and this is the copy, the multiplier is 2 or the scale factor is 2. If these 2 were switched around and this was my original and this was my copy, then the scale factor would be 1/2 because it's half the size. So the way that we write scale factor is we do copy over original. Now every single part of this shape has to be, or every set of corresponding sides has to be equal to 2. So my copy, let's say we do this one. We'll put 3 lines here. So copy is 8, original is 4, 8 over 4. That has to be equal to, let's do the 2 lines one, 4 over 2, which has to be equal to those 2 that correspond, which is 6 over 3. Now, to be sure, we could reduce them all. So 8 divided by 4 is 2, 4 divided by 2 is 2, and 6 divided by 3 is also 2. So in this case, these shapes are similar because every set of corresponding sides has the same multiplier, which in this case is 2. So let's look at another example. So we have these parallelograms now, and this is the original, and this is the copy. So let's say we have 4, 4, 3, and 3. And we want to know if they're similar, let's say. So let's say this is 2, 2, 1.5, 1.5. I might ask you, are these 2 shapes similar? And you would have to say yes or no, and then you would also have to tell me the scale factor. So if this is my original and this is my copy, we know that it's getting smaller. So my scale factor has to be less than 1. So let's find some, so this side length corresponds with this side length. Okay, and again, copy over original. So here's my copy, 1.5, and my original is 3. Okay. Now you might not know right off the bat, but this is actually half. Okay, so this is 1/2. So right now, the scale factor we believe is 1/2 based on those two side lengths. Now, these are the same, 3 and 1.5, so I'm not going to check them. I know that those also are related by a 1/2 scale factor. So I might check my bottoms here. My copy is 2, my original is 4, and that also equals 1/2. So I would say yes, similar, and I would say scale factor 1/2. Okay. So the scale factor or multiplier in this one was 2 because the copy is twice as big as the original. And in this one, our scale factor is 1/2 because when we put our original into the copy machine and out came our copy, it was smaller, and that means it has to be less than 1. And that is 1/2 the size, actually. Okay, so that is similar figures.